All right, this is force vector practice. The kids in class actually did this with me yesterday, Tuesday. But this is for anybody that's out of class right now. And we're just going to go over some of these practice problems. I'm not going to do them all for you, but I'll do about half of them. And then the other half you can do on your own. All right, so the first one says a force of 10 newtons up and a force of 10 newtons down. I wanted you to try to draw your force vector arrows proportional to the boxes, but I'm really not too worried about that. So what we're going to do is we're going to just draw a box that represents whatever object the forces are acting on. And then I'm going to draw my force arrows. I'm going to draw one pointed up, label it 10 newtons. One pointed down that's about the same length, label that 10 newtons. In this particular situation, I drew the two arrows kind of as a pull. So if you could think of maybe a rope pulling and a rope pulling. I can actually have the same situation if I decide, well, I'd rather draw them as pushing forces. So I could have pushing down and pushing up. I still have, in both situations, I still have a 10 newton up and a 10 newton down. But like I said, this would be kind of like if the forces were pulling forces, if the forces were pushing forces. And frankly, you can have a combination of the two. All right, the bottom line is, what is the net force on this particular object right now? The net force is going to be 0. The reason why you've got a 10 newton up and a 10 newton down, they are equal and they are pointed in the opposite direction, so you're going to subtract them. And if the net force is 0, then the forces acting on this object are considered balanced forces. The next question is, will the object accelerate? In this case, there will be no acceleration. And there is no acceleration because the net force is 0. If the net force is anything other than 0, then the object will accelerate. Another question that I asked the kids yesterday was, could this object be moving? And I got some yeses and some nos, and then I clarified and I said, well, how about this? Can this object be changing the way it's moving? Because changing the way it's moving really is describing acceleration. So this object can't be accelerating, so it cannot be changing the way it's moving. It could be an object that's already in motion at constant velocity. Who knows? But all I know is that there is no acceleration. Okay? All right, we're going to move on to the next one. And the next one has a force of 10 newtons to the left and 5 newtons to the right. So I can draw 5 newtons to the right, 10 newtons to the left. I can do it like that. I can draw the 10 newtons as a push and the 5 newtons as a push. I can even draw with a combination. Maybe the 5 newtons is a pull and the 10 newtons is a push. But the bottom line is, what matters is not whether we draw it as a push or pull force. What matters is the direction. So in all three cases, the situation winds up being the same. 10 newtons points to the left, 5 newtons points to the right. Okay? In this case, your net force is going to be 5 newtons. And we also have to state which direction the net force acts. So the net force is going to be 5 newtons to the left. And the reason why it's to the left is because the bigger of those two forces points to the left. So kind of the bigger force wins. All right. So in this situation, I do have acceleration, so I'm going to say yes. And the reason I have acceleration is because I have a net force that is something other than 0. So I have a net force of 5 newtons. So yes, this object is going to accelerate, and it's going to accelerate to the left because acceleration is always in the same direction as the net force. Now, you can't tell me how much this object is accelerating. You can just tell me yes it is or no it's not, because there's some missing information. In order to calculate acceleration, you have to not only know how much is the net force, but you also have to know the object's mass. Because you guys should know, kind of just common sense, that if I shove on something that's really, really big and heavy, I'm not going to be able to move it or accelerate it very much. If I shove on something really light, it's pretty easy to move. So mass is going to play a factor in how much acceleration you get. So for right now, because you don't know the mass, all you can tell me is yes, it's accelerating, or no, it's not. Okay, we're going to skip number 3. I think number 3 you can probably do on your own. And we're going to tackle number 4. Again, I'm just going to draw a box to represent whatever object the forces are acting on. And this time I have 3 forces. I have a 5 Newton force acting to the left. I have a 20 Newton force acting to the right. And then I have another 10 Newton force acting to the left. So I can actually tack it on here and make them all pulling forces. I could take that arrow and put it over here and make that one a push. As long as it's facing to the left, we're okay. All right. So let me draw an alternate situation. I could do 5 newtons here, 20 newtons, and 10 newtons. And I could decide that that one's a pushing force. But it doesn't matter because the 5 newtons is still pointed to the left. So in both situations, we're going to wind up with the same result. Now, we have 2 forces pointing to the left. One is 5 newtons and one is 10 newtons. If they're pointing in the same direction, then add them together. You can consider them one single force of 15 newtons. So really you have 15 newtons to the left and 20 newtons to the right. 15 to the left and 20 newtons to the right, those are in opposite directions. So you're going to say 20 minus 15, and you're going to get 5 newtons. And the direction of your net force is going to be to the right because that is the direction of the larger force. Okay? Will the object accelerate? And the object will accelerate, yes. And it's going to always accelerate in the direction of the net force, so the acceleration is going to be to the right. All right, flip your paper over and we're going to do, I think it's number 8 together. All right, on number 8, at first it might look really complicated, but it's not. Let me go ahead and draw everything. I'm just going to draw everything as pull forces. So 20 newtons up. I have 5 newtons to the left. I have a force of 5 newtons to the right. And I have a force of 10 newtons down. All right, and at first you might panic because you've got 4 different directions, but really this one is not a big deal. If you will notice that these 2 forces right here, 5 newtons to the left and 5 newtons to the right, these 2 will cancel each other out because they are equal in magnitude and they are opposite in direction. So really all you're left to deal with is 20 newtons up and 10 newtons down. So the net force is going to be 20 minus 10 because they're pointed in the opposite direction. So 20 minus 10 is a net force of 10 newtons. The larger force wins, so the net force is going to be directed up. Will acceleration happen? Yes, because there is a net force of something other than 0. And remember that acceleration is always in the direction of the net force, so this object will accelerate up. All right, again, I can't calculate exactly how much the acceleration is because I'm missing mass. And in order to calculate acceleration, I have to know both force and mass. All right, what I'm going to do is I'm going to go back and write in the other answers, and you guys just pause here, work the other 4 problems before you check them yourself. Okay, so here is number 3, and then I'll show you the ones on the back. All right, here's 5 and 6. And finally, this is number 7. So just check, make sure you understand how to do these. Let me know. Send me an email or a private comment if you're still having trouble.